So this is a cliff problem, okay? And I'm going to zoom this thing in. There we go. Okay, so am I still on there? I still am. Okay, so here it is. There is the level ground. This is the cliff. Let's make the cliff be 6.7 meters tall. I doubt it really was. It probably was like 15 feet, but it gets taller every time I tell it, Okay, here I am running this way. Let's give me a velocity of, I don't know, how about 5 meters per second? That's about 11 miles an hour. I think I could probably have run that fast. We'll say 5.0 meters per second. Let's draw the giant grown-up guy. Grrr. Grrr. Right, and I'm like, I will die now. Okay, and here's what we want to know. We want to know, of course, where did I land? What's this distance here? Right. I also want to know. The instant that I land. Okay. I want to know what that velocity is. I know I'm moving in two directions. I know I'm moving sideways, and I know I'm moving down. So just before I hit the ground, what's my horizontal velocity? What's my vertical velocity? And then what is this as an angle magnitude vector? Yeah. So we're going to find this angle. We're going to find this magnitude. What else could we do? Oh, how about the time in the air? It seemed like I was in the air for like hours. It's like still falling, right? It was very strange. Rob was ahead of me. I remember him falling into the shadow of the hedge before me because he was just a little faster than me, always. So let's do that. Now, the good news is, and this could be bad news, depending on how you did on the test, okay? But the good news is that we're still going to use our little formulas, right? So x is still 1/2 vi vf times t, right? We're also going to use v final is v initial plus acceleration times time. We're going to use x is vit. So they're the same equations we used. Remember that? Only they get this formula, Max. Okay, so let's see. And then we've got v final squared is v initial squared plus 2ax, right? Okay, that's good news because those are our old friends, and that's why we taught you that. The other good news is that we're going to be able to solve these things independently. X is not going to affect y. X is not going to affect y. So we're going to do horizontal. Horizontal is like in this direction. Vertical is in this direction. Okay. And this is what you do. You set up one of these little guys, a horizontal, vertical table. Now, there's one thing that these guys will share. I don't know if you noticed it, but we just showed this, right? When we shot one ball out and one ball fell down, didn't they hit the ground at the same time? Yeah. So the horizontal and vertical will share the time. They've got the same time. Okay? Now, who knows what we know and where it goes? Because that's the next step. Initial velocity in which direction? Horizontal, what is it? 5 meters per second. The initial velocity in the horizontal direction is 5 meters per second. I will not argue with that. What else do we know? Initial vertical velocity is 0. This is usually I have to tell people that, right? This is true for, I call them cliff problems. Cliff problems are problems where you just run off a cliff like that. I didn't jump up, wasn't projected downward, I just had only horizontal, therefore I had no vertical velocity, correct? Does that make sense? Okay. This is only true for this kind of problems, but we'll solve a lot of these problems. Yeah, Alex.
Vertical x is 6.7.
Yeah, so I'm gonna say negative 6.7 because we end up going 6.7 down. But if you secretly make the down direction positive, in the privacy of your own home, there's
Vertical acceleration is
negative 9.8. There we go. You guys are like advanced, talented, and gifted. Okay, and then there's one more thing. Let's assume assuming that I don't have any form of propulsion, once I leave the edge of that cliff, can I change my horizontal velocity? This is assuming I don't have a jetpack or I haven't recently eaten at Taco Bell, right? Okay. Yeah, my acceleration, thank you for laughing. Okay, my acceleration horizontally will be 0, correct? Yeah? So that means that this guy will be 5.0 meters per second. Now, this is one of these golden things. This is always true. This is true on Earth. And we're going to solve all our problems on Earth. So those things in boxes, those are always true. These guys are always equal, right? These guys are always equal. Always. Now, I suppose you could go to college and they might give you something where the guy's wearing a jetpack. You could deal with it then. But I'm not going to do that. We're not going to go there. Okay? Now, that's the first step, is to just fill this in. Now, if you're keeping score, we know 3 things in the vertical direction, don't we? Yeah. And although we know 3 things in the horizontal direction, we still can't solve the horizontal direction yet. Okay? And it's because the formulas will just give us zeros. When there's no acceleration, here are the players. And this is always true. The players are this, these guys, and this guy. Right? The formula is just always V is x over t. Right? So x is vt, t is x over v. Right? Horizontally, this is all we do, because remember, when there's no acceleration, those are the only formulas. You don't have to do any acceleration formulas, do you? So the horizontal direction is always dead simple. It's just a constant horizontal velocity for however long you're in the air. And the vertical direction is just as hard as any of the little kinematics problems we've ever solved, right? So let's just solve this through. I'll show you how to do this. The next step is to just solve. I'm going to choose to find the time, and I'm going to use 1/2 at squared. I'm going to use this guy, right? This is my personal preference. So I'm going to go x equals vit plus 1/2 at squared. What's my initial velocity? 0, isn't it? So this goes away. X equals 1/2 at squared. And this is what it always is if you don't have initial velocity, right? Okay. So now I can just plug it in. Minus 6.7 equals 1/2 negative 9.8 t squared. And then I can solve for t. Okay, square root of 2 times 6.7 divided by 9.8. So it seemed like an eternity that I was in the air, yet it was 1.169 seconds. And when you do these problems, don't round these off. Just keep them, like maybe carry 4 or 5 digits, right? Now, do you want to see a neat trick? These guys are always independent. I'm never going to use this number with this number, or this number with that number. These guys are totally independent, but time is the same, so I can castle this guy across. 1.169. Once I find the time on this side, it's the same as this side. That's pretty slick, isn't it? That's why I always find time first, right? But we still need final velocity, so let's solve for final velocity there. Okay? My choice at this point, you could just use VF as VI plus AT. Maybe I'll just use that. I'll just use that. It doesn't really matter. VF is VI plus AT, right? The initial velocity is 0. Notice I'm not going to use that. Don't use this because it doesn't go with vertical. I'm doing vertical stuff now, right? So I go VF is 0 plus negative 9.8 times 1.169. I'm going to take this number and multiply by 9.8, or negative 9.8. Negative 11.46. It's negative because the acceleration is negative. Remember, if you use this formula to find the final velocity to make it negative, right? We're almost done. We just have one more thing to fill in, right? And I'm going to use this guy. X is v times t, which is just from this formula that's in your formula sheet, right? Okay, so all I have to do is multiply 1.169 by 5, and I'll get this, right? So I was going 5 meters per second the whole time I was in the air. The distance I go is this times this, right? So 5 times